Welcome to this presentation on mastering advanced auditing techniques with Spring JPA for enterprise Java applications. Today, we will cover various topics such as custom revision entities, field-level auditing, performance optimizations, and more. Let's dive right in. Auditing is the process of tracking changes made to entities in a Spring JPA application. With auditing, we can automatically generate metadata for entity modifications, such as the creation and modification timestamps, and the user responsible for the changes. Spring Data JPA provides built-in support for auditing, making it easier to implement in your applications. Custom revision entities allow you to store additional metadata about each revision beyond what Spring JPA provides out of the box. To create a custom revision entity, extend the default revision entity class and add your custom fields. Implement a custom revision listener to populate the custom fields when a new revision is created. Field-level auditing involves tracking changes at the field level rather than the entity level. Implement field-level auditing using a custom entity listener that compares the old and new field values of an entity. Generate field-level audit records for each changed field. Use the post-update lifecycle event to trigger the field-level auditing process after an entity update operation. To integrate Spring Data JPA auditing with Java EE or Jakarta EE applications, use CDI, context, and dependency injection to inject the auditor-aware bean. Implement the auditor-aware interface with Java EE security components, such as Identity Store Handler, to retrieve the current auditor. For complex queries on audit data, you can leverage the Criteria API. We provided an example of querying audit data for a specific entity and date range using the Criteria API in the post linked below. In a microservices architecture, you can implement auditing using a distributed log like Apache Kafka. When a change occurs in a microservice, publish an audit event to a Kafka topic. Use a centralized auditing service to consume these events, process them, and store the audit data in a separate data store. Partition your audit data store by date or another suitable criterion to improve storage and query performance. Create indexes on frequently queried columns in your audit tables to speed up search and retrieval operations. Use Hibernate's second-level cache to cache frequently read audit data, reducing database load. Offload auditing to a separate thread or process to prevent it from affecting application performance. Use Spring's Async annotation or messaging systems like RabbitMQ or Apache Kafka. To protect sensitive audit data, you can use JPA column annotation to enable column-level encryption. Ensure that your database supports column-level encryption and configure the appropriate encryption keys and algorithms to maintain data integrity and security. In this presentation, we've discussed advanced auditing techniques with Spring JPA, including custom revision entities, field-level auditing, performance optimizations, and more. Auditing is essential in enterprise applications where tracking data history and changes is a critical requirement. With Spring JPA, you can implement and optimize auditing to meet the needs of your large-scale enterprise application. Visit our site linked below for code examples and detailed how-to guides on implementing auditing with Spring JPA. If you enjoyed this content, like this video and subscribe to our channel.